Now I would like to invite next speaker, who will be Mrs. Ivana Vojtíková from the National Radiation Protection Institute in Prague. Not Ivan. Sorry, so Katerina. Katerina, she will tell us stories about from the past and challenges for the future regarding norm and building materials.
Maybe.
If you want it, is just
Okay.
quick.
Okay. And what should I use for?
You can.
So?
Yeah.
Yeah.
I didn't forget. So
I wasn't sure what does it mean. Like,
Yeah.
why? Finally at the end. Okay. Good afternoon, ladies and gentlemen. I would like to present you stories from past. Yes. On behalf of my co-authors, who are Ivana Ženata and Ivana Vojtíková, who are much more experienced in this topic than I am, but I will try not to ruin the topic. So the circular economy is a very popular and important topic to be discussed. And it was not a new topic. It's quite old because people are trying to reuse and recycle materials, which for someone looks like waste, but for the others, it's still valuable material. And also we are pushed a bit by the economy because the raw materials are getting more and more expensive. If we want to reuse materials, we have to be aware how they can influence our product. And of course, this is strongly related to our knowledge, which changes in time. And this, of course, is not only for natural radionuclides present in construction products, but for many other things like toxic metals and so on. But today I would like to talk about the old story which we have in Czech Republic, the case study of start houses and how we can benefit now from the past. So let me describe the case study. For some of you who already know the topic, there will be nothing new. But for those who saw this for the first time, I will briefly describe what happened. So there was a small power plant burning a coal, surprisingly, but some of the coal had elevated content of radium and uranium, and the slag was valuable material also like 50 years ago. So the state enterprise Prefahiskov produced slag concrete panels out of this slag and built several apartment houses at the beginning of 60s last century. Then by a surprise, elevated gamma dose rates were found, and the use of this slag was prohibited by the Ministry of Health. But during the changes in ownership in 1968, the information of this contaminated slag was lost, and the slag was used again for production of concrete panels, which led to more than 3,000 single-family houses built out of these slag concrete panels. You can see on the picture how they looked like. There was a standardized project for these buildings. What about the radiological surveys in these houses? Well, the concrete panels were used for supporting and peripheral walls and also for building a chimney. So, and the rest of the walls was from standard bricks. So the variation of gamma dose rate was quite high in the building. There was an extensive measurement campaign in between 1989 and 91 to determine the situation in individual houses. They found all the owners, all the houses, and measure in all of them. So, for example, from Prague region, you can see the charts of the distribution of equivalent radon concentration, and you can see that that was not that extremely high. But you can see also the distribution of gamma dose rate, which was quite spread from below 0.5 microgray per hour up to 2 micrograys per hour. But these were quite few cases. What is important point here is that the emanation coefficient of radon was quite low, only 2 or 1 to 5%, which causes not that high radon concentration indoors. The situation and the discovery of this case caused changes in the legal framework of the Czech Republic, Czechoslovakia at that time. At first, it was applicable only to start houses, and there was a recommended value by ministry on indoor radon concentration and indoor gamma dose rate, and there was defined a summation criterion, mainly used for decision on remedial measures with governmental support. No other actions on building materials and radon was taken at that time. But after the Velvet Revolution, there were a lot of people who wanted to solve the situation with their houses, which causes also further development of the legal framework and resulted in several steps or several implementation steps of protection against elevated concentration of natural radionuclides in building material, and also radon concentration indoors was reflected in this decrees or legal legislation implemented in the Czech Republic. So you can see, I will not go into detail because you can read it, but just to point out that from the beginning, from the discovery of the start case or Prefahiskov case, there was at the beginning the criteria was quite strict for habitable buildings. The mass activity concentration of radium-226, the allowable was only 120 becquerels per kilogram, which is quite low for current for present days. Then it was a bit exceeded, and still there was an action level and limit value, because it reflected also the exhalation of radon from the building material. So you can see that there was a distinction between habitable buildings and non-habitable buildings. And also the building material was not building material itself, but also construction materials. I mean, building material, it is understood by the EU BSS currently. Then the next step was the implementation of activity concentration index. And still there was a distinction between requirements on the activity concentration index and the limit value for radium-226 as a source of radon. Skipping from a legal framework development to the standard life, thanks to the effective legal framework, there was no more issue with building material contaminated with natural radionuclides which were not available on the market anymore. But still we had the start houses, and they changed the owners over the time. They were inherited or sold. And unfortunately, a lot of information has been lost during the time, like on purpose or just lost. And the elevated exposure to radiation has been also subject to several lawsuits. And as time went, then start houses were not, for some of the owners, were no longer acceptable. I mean, this for the modern style of living. So they were reconstructed or demolished because the land has had a much higher value than the building itself. So let me focus on the reconstruction, which usually for these old buildings is focused on to reduce the cost for heating. So they were thermally retrofitted. And on this table, you can see the influence of thermal retrofitting on the radon concentration indoors. By thermal retrofitting, we just put some insulation on the peripheral walls, so you cannot influence the gamma dose rate, but you can strongly influence the radon concentration by reducing the ventilation rate, as you can see on the from the results presented in the table. Just for your information, it was long-term measurement, 1-year measurement before and after implementation of this thermal retrofitting. And by radon diagnostics, it was proved that the reduced ventilation rate is responsible for increased radon concentration. And well, yes, there is mitigation available, improved natural ventilation or forced ventilation with heat recovery. So jumping to modern days, or it's not that the development of regulatory framework continued slowly. We implemented the EU BSS, the latest directive in Czech legal framework. So we have now reference level for radon concentration, which is often exceeded in the start houses compared to the situation before. The reference level for gamma dose rate, which is 1 microsievert per hour, which is usually not exceeded. The produced building material, which is only for habitable buildings, as it is prescribed by the EU BSS, is under control. There is a requirement on the activity concentration index and the reference level for external exposure indoors. It should be less than 1 millisievert per year. But we lost the requirement on maximum content of radium-226 in the building material. What I would like to present you now are brand new data we have in the Czech Republic, and they are connected to air exchange rate measurement. I mentioned before that air exchange rate is quite important when we modify our buildings to modern style of living, which usually requires reduced cost for energy and low energy consumption. So air exchange rate is defined as the flow rate through a building normalized by its volume. And on this chart, and on the next slide you will see it in more detail, you can see the monthly average air exchange rate measured in nearly 300 dwellings, which was done as a part of a research project, which is going to the end in the Czech Republic. It's basically the representative survey of radon, and this was connected to it, the measurement of air exchange rate. So you can see that it's by month, and there is like nice variability during the year that you can see. I will try to use the laser, the pointer. Somehow you can see that January, the winter period and the summer period differs a lot. That during the summer there is a like the ventilation, the air exchange rate values are quite broadly distributed. During the winter, they are quite close and people safe. They are not ventilating much. So here you can see it in more detail. And also we added 2 lines representing the minimum hygienic standard ventilation, which is 0.3, and this value is prescribed by the technical standard applicable in the Czech Republic for habitable rooms. And also 0.5, which is since 2012, the minimum required air exchange rate in habitable rooms by a decree on technical requirements for buildings, but also this value, 0.5 changes per hour, are perceived by the IEA TechDoc 9051 as the air change per hour, which is typical exchange rate for some workplaces and dwellings. And you can see on the chart that it's not that we really do ventilate much less. So why it is important for reuse of non-residues? If we have much lower ventilation rate, then having the same activity concentration and emanation rate, we will get much higher radium concentration in the building, which is built out of this material. We were lucky that the slag concrete panels had very low emanation coefficient or exhalation coefficient, around 2% only. And the gas silicate bricks have 10 times higher emanation coefficient, which I know it's conservative calculation, but the radium concentration, they may reach up to 4,000 becquerel per meter cube. So by this, we want to emphasize that it should not be forgotten that the building material is, yes, it's source of gamma radiation, but it's also source of radium, which is released from the matrix. Few more comments on the reuse of residues. The EUBSS focus on building material, which means the construction products which can be used for building of habitable buildings, to build habitable buildings. But there are also products. The manufacturer can like put on the market a product, which can be, for example, a recyclate, on which there are no requirements on content of natural radionuclides. So we see this as a way how there can be some uncontrolled movement of possibly contaminated material can be again put on the building market. Fortunately, there is something which is called, or which will be called, a digital product passport, which probably may help to overcome this issue once it is implemented, and it's still under discussion, as I was told. So coming to the summary, definitely it is beneficial to use norm-based products, byproducts, residues. It depends how you call it, because it's better to use them rather than to dump them to the landfill. But we have to know their properties, and also among the physical and chemical properties, which are usually being tested, we have to know their activity concentration, the activity concentration of the radionuclides. Otherwise, the history may repeat. Regulation of both the content of natural radionuclides and radon exhalation is gaining importance, especially because the ventilation of the buildings is low, as you saw on the picture, on the box plot. And fortunately, there is still limited harmonization between indoor air quality programs, energy saving programs, and radon action plans. Actually, it was proved also by Tanya Perko's study. And the last comment, we should keep the communication channels open, even for the cold cases, to remind people what happened in the past so they can benefit from it in the future. Thank you very much for your attention, and I would like to welcome you to Prague conference, which will be in September this year. Everyone is welcome. Thank you.
Thank you very much, Katerina, for a very illustrative presentation. So we have time for a few questions or comments. Are there any? Huh? Bernd? Oh, Francesco.
Thank you very much for this very nice presentation. I just would like to reinforce one of the key elements of your presentation, which is that we are going to pay attention with a new directive about the gamma radiation emitted by building materials, but we should not forget radon exhalation from building materials. And in terms of those, we have to remind that more or less about 1 millisievert from radon corresponds to about 30 becquerel per cubic meter in dwellings, which is not difficult to be exhalated, to be due to exhalation for building material. So it is not that can occur in rare case, but on the opposite, something that could occur in much more cases that we expect. Thanks.
I thought it was comment.
Yes, it's a comment, but of course, your comment on my comment is appreciated as well.
Thank you for your comment, Francesco. I fully agree. 1 millisievert for radon for annual for the standard time spent at home, it's quite low. And we have to regulate radon separately.
So, any other questions?
Yes, I have a question. Thank you, Katerina, and also Ivana, for this excellent study. I would first like to encourage you to write a scientific article about this case. And the next thing is, if you can advise us, where are the references on these kind of cases? Because we were looking also from Czech Republic, also from Sweden, also from Slovenia, where they have used different norm materials for the buildings, and they have people extremely bad experiences also with the blue concrete and so on. And we are not able to find any scientific reference that we can use in our articles to refer that people have bad experiences. We are just taking this from somewhere, but we cannot put any why is this? Why are not references? And please write an article about this so that you can refer and claim that people have bad experiences from this kind of using of norm into the building materials. Thank you.
Thank you, Tanya, for this comment. Yeah, we will do our best. I'm surprised with Swedish that there is no reference. For this, I'm quite surprised because I thought that there were many publications on. Martin, you probably can comment because you you were involved in mitigation planning.
But unfortunately, it was written in Sweden. So and in the 90s, so it's an old and probably not on the web pages. So it's only in written form and in Sweden.
Thank you very much. Actually, there are some papers on this particular case. The problem is that it's not really feasible or easy to identify, since there are some common issues regarding keywords like radon diagnosis, etc., which is not clearly linked to the radionuclides in building materials. So there are some papers we can send you. No problem at all.
There are some of these, but the history, I think it was never published in English. I mean, the
I
history.
remember we have published, yeah, regarding the start houses, we have published the energy consequences if you make an energy conservation of such buildings. So
This one.
we have published some yeah, in radiation protection dosimetry.
It is important, but it's not the beginning of the story.
Yeah, yeah,
I understand.
yeah.
Yeah.
And Bernd, if I remember well, Bernd has raised his hands. Bernd, are you there?
Yes, I'm here. Thanks, Katharina, for your nice presentation. I want to point a finger on one topic. You said something about reuse of this material. Indeed, this will be a hot topic in the next few years in general, not only because of radiation protection and high content of radium, thorium, and potassium, but also because of other substances inside building materials. The sustainability, difficult word for me, is one of the key messages from the novel European construction product regulation. Not easy to handle from this change from gravel to change the system that you can reuse material independent on the content of heavy metals and VOC and all the other stuff which is inside. So radiation protection will be a part of these discussions, and I'm not sure if this will be really a problem for us, but we have to keep an eye on it.
Exactly. We have to keep an eye.
Yeah, okay. Thank you very much.